Hello students, welcome to ePathshala. Myself Dr. Pradip Samanta from Postgraduate Department of Geology, Durgapur Government College, Burdwan University. My topic today is global and regional stratigraphic cycles. Most of the natural events are cyclic, as we know about carbon cycle, nitrogen cycle. Likewise, geological events are also cyclic. This cyclicity develops due to regularly alternating beds traceable over long periods, long distances, and sometimes repetition of even larger units referred to as depositional cycles. Most of the natural events are cyclic, as we know about carbon cycle, nitrogen cycle. Geological cycles are evidently cyclic. This cyclicity develops due to regularly alternating beds traceable over long distances or sometimes repetitions of larger units referred to as depositional cycle. Cyclic sedimentation occur worldwide in various scales for almost all sedimentary environment and stratigraphic system. This cyclic sedimentation has attracted the sedimentologists for a long time, but their origin is still debated. Common example of cyclic sedimentation is cyclothem, which are packets of lithosome representing the smallest unit of a succession. Cyclic phenomena are important in stratigraphic correlation and probably dating the geological events of sedimentary succession. Sedimentary cycles are composed of at least 3 different beds or interbeds from which that form a repeated succession. The succession of beds and interbeds may be symmetric, semi-symmetric or completely asymmetric. The sequence stratigraphic In sequence stratigraphy, this cyclicity is represented by depositional sequence bounded by distinctive lower and upper boundaries and accordingly termed as low stand, high stand and transgressive deposits. Smallest unit of this sequence is a parasequence. These cyclic units are representative of geological events and are represented in stratigraphic record. These cyclic events may have global or regional extent and their time correlation being the key to reconstruct the global stratigraphic framework. Now, the recurrence time of these cyclicities. The recurrence time of cyclic processes in sedimentary environment varies in scale. Individual bedding couplets are often in the same ranges, indicates that they may be produced by sedimentological events, that is event beds, or by gradual cyclic changes. Many common features such as turbidites etc. may occur in span between 10 to the power 3 to 10 to the power 5 years. Both kinds of bedding rhythms can found in the same sedimentary succession. Distinction between cyclic and dicyclic bedding of the frequencies become difficult. However, if the sedimentation rate is higher, as in case of lake, thick package of sediment that produce thick package of sediment, and in that case this event bed can be easily distinguished because they are relatively smaller in their dimension. Now, hierarchy of these stratigraphic cycles. Sedimentation cycles operated by various processes including regional and global tectonics, eustatic sea level changes, climatic changes and also due to variation in discharge in case of fluvial system. Biological process such as mass production of new organism or extinction of pre-existing organism and repeated biological event may have significant information in the sedimentary record. The cyclic phenomena of different order and frequencies may superpose, thus results a complicated multi-pattern cyclicity. To understand the stratigraphic cyclicity, one need to understand the sequence hierarchy. Now, the order of sequence hierarchy and their correlation. In sedimentary system, the depositional unit represent a hierarchy of scale from the very small scale ripple laminae to the scale of entire basin fill. A classification scheme of stratigraphic sequence using rank order has been introduced in this table. Now, the table that is given by Vail et al. Is shown here, where the order and the time duration and formation and their origin has been shown. Order 1 which has duration more than 50 million year, and origin is formation of sedimentary basin. This is the origin is tectonic or consequences in their distribution. This is almost regional in scale and major continental flooding epochs. 2 duration of 3 to 50 million year, specific phase in the evolution of sedimentary basin, major transgressive regressive phases cycles, and in eustasis it is sequence cycle. Now, in order 3 of duration 0.5 to 3 million year, flooding, magmatism, diaparism, disturbances of general transgressive regressive trends, and these are sequences with system tract, and less than 0.1 million year which are parasequences and Milankovitch cycles. However, the recurrence time and frequencies has been questioned by various workers. It is accepted that a hierarchy of sequence exists in the stratigraphic record, but their distinctiveness in terms of duration and recurrence interval cannot be approximated by thickness. The classification of stratigraphic succession based on measurement or assumed duration is more or less subjective. A more objective approach has been proposed by Emery in 1995 based on some key descriptive character of the sequence themselves, such as amount of deformation and the degree of phases change at the sequence boundary. Mathematical model of sequence cyclicity has been proposed to demonstrate the duration of any length may be expected to occur from thousands of years to thousands of million years. The sequence classification is only possible because some of these cycles correspond to the productivity of some natural processes. So, in case of fluvial cycle, sedimentation needs fluvial architectural element analysis and to further includes bounding surfaces. These bounding surfaces within fluvial succession also follows a definite hierarchy. Higher order bounding surfaces are regionally extensive and basin wide and are excellent stratigraphic marker and useful for stratigraphic correlation between detached section. Here is a diagram from which the different order of sequence boundaries can be seen in case of fluvial system. Look at the figure. Here the different bounding surfaces has been shown in different colors. Lamina bounding surfaces has been designated as 0 order, lamina set bounding surfaces as first order, co-set bounding surfaces as second order, and successive higher orders of surfaces that bounding the stratal packages of progressively larger scale. Look at the figure here. This is the largest bounding surfaces which divides two division. This is division 3 and another which the lower one is division 2, and therefore, the lower order surfaces which encloses by these higher order surfaces. Each of these cycles have been referred to as their respective time interval. An allo member consisting of sequence sets and composite sets may itself be subdivided into cycles representing 10 to the power 4 years of sedimentation. Therefore, each of these units constitutes a parasequence and their boundaries would be classified as 6th order bounding surface in the Mayal classification scheme. However, the parasequence may be developed due to autogenic process. 4th and 5th order sequence in sequence stratigraphy classification are those with cyclicities of 10 to the power 5 to 10 to the power 4 years respectively. Outcrop based architectural description have been utilized for bounding surface classification of Mayal and Neo and Young. Small scale units were used to combine them into larger macro forms such as small channels and bars by mapping them into facies units. In contrast, the sequence nomenclature represent ever more refined larger subdivision based mostly on geophysical studies of larger time span and duration and represent larger stratigraphic unit. Sequence hierarchy and bounding surface codes for the two systems are given here. Now, look at the table where the two system has been introduced. Look at the table here, the three system of nomenclature has been shown and their sequence duration. First one by Weil et al, second one by Mayal and Neo and Young, and the third one, the third column, which is proposed by Mayal in 2010. Look at the table, 10 to the power 6, that is the time duration for third order sequence boundary, which is in Mayal case 8a, and Mayal 2010 proposed, which is allo formation, and 10 to the power 5 time duration, which is in Weil's classification scheme 4th order sequence, and in Mayal and Neo and Young model, that is 7a, and in Mayal 2010, that is allo member, and 10 to the power 4, that is the time scale for 5th order sequence, which is in Mayal and Neo and Young, that is 6a and fb, and in Mayal 2010, that is allo member or sub member, and 10 to the power 3 to 4 million year duration, that is in case of Weil et al, that is parasequence, and Mayal, Neo and Young named as 5, 6a, e and fb, and the latest, which is Mayal 2010, which is known as facies succession. However, there are many overlaps and confusions in the nomenclature system, particularly Mayal's group 8 and 9 in the previous table. Higher order low frequency bounding surfaces may also develop by autogenic process. For example, switching of delta lobe resulting from the major channel may also produce vertical succession is very similar to that of stratigraphic sequence of high strength system stack. In hierarchical stratigraphic terminologies described by different authors have been correlated, and it is an attempt to set out the relationship among them. So, look at the table here, the sequence type, time duration and different terminologies used by different authors. First one, global supercontinent cycle of duration to 200 to 400 million year, which is termed as first order cycle by Weil et al 1977. The cycles generated by continental scale mantle thermal process and plate kinematic, that includes eustatic cycle induced by volume change in global mid-oceanic spreading ridges, mid-oceanic spreading center, regional cycles of basement movement induced by extensional downward and crustal loading of 10 to 100 million year, which are included as second order cycle by Weil et al, super cycle by Weil et al, or sequence by Schloss in 1963, whereas the regional to local cycles of basement movement caused by regional plate kinematics including changes in interplate state regime of 0.01 to 10 million year has been termed as third to fifth order cycle by Weil et al. In 1977, third order cycle also termed by mega cyclothem by Haeckel in 1986 or mesothem by Ramsbottom in 1979. And the last one, the global cycles generated by orbital forcing including glaciostasy, productivity cycles etc. of duration 0.01 to 2 million year are designated as fourth and fifth order cycles, fourth and fifth order cycles by Weil et al. 1977, Milankovitch cycle cyclothems by Wanless and Wheeler in 1932, major and minor cycles by Haeckel in 1986. So, it is now accepted that in studying modern environment that hierarchies of cycles are also common in rock record, but their duration of the constituent cycles are different. The genetic reason for this cyclic sequence are also variable. To solve this confusion, a non-genetic stratigraphic nomenclature has been proposed by Mayall. The rank order classification of sequence of first to sixth order proposed by Weil et al. In 1977 has been criticized by Embry in 1993 and 1995 on the basis that the classification is not based on any descriptive parameter of the cycles, but only their time span, which is often poorly known. Embry in 1993-1995 proposed solution to define a 5-fold classification of sequence based on 6 descriptive criteria. Number 1, the areal extent. Number 2, the continuity of unconformity throughout the study area. Number 3, the extent and degree of deformation at the strata underlying the unconformity. Number 4, in case of deepening the magnitude of the sea that results the flooding of the basin margin and the extent of the transgressive strata overlying the boundary. Number 5, the change in sedimentary system across the boundary, and number 6, the change in the tectonic setting of the basin and surrounding area across boundary. The application of this criteria to a sequence classification is illustrated in this diagram. Look at the figure. This is a hypothetical representation of stratigraphic cycle proposed by Embry in 93-95. Note that the sequence from the bounding surfaces of different order across basin margin to basin center, and different order of cycles has been shown, and this is for subaerial unconformity, and the second which is of first order, the second order surfaces are conformable transgressive surface. So, from the basin margin to basin center, sometimes the unconformity may be correlated with their correlative conformity, which is of second order. So, the different order surface can be shown in this way, where note the sequence contain a sequence boundary with the same or lower order than its highest order boundary, and the order of a sequence is determined from its highest order boundary. That is, the sequence would be of that order where the bounding surface is the maximum. So, now let us discuss about the major types of stratigraphic cycles. The stratigraphic cycles can be classified into 4 basic types ranging in extent from global to regional. Each of these cycles operates due to at least 4 types of primary process, including global sea level changes and regional tectonism, implication of tectonic mechanism to determine the relative importance of other process of the major is the major thrust area of modern research, but that are comparable in frequency, span and areal extent. These other processes include magmatism or volcanicity, climate change, change in ocean water circulation pattern, carbon sequestration and organic productivity, all of which are recorded in the stratigraphic column. These cycles genetically can be subdivided into two basic kinds, autocyclic and allocyclic sequence. Autocyclic process are controlled by autocyclic sequences are the process that are controlled by the sedimentary basin itself. That is the process, those are taking place within the same sedimentary basin, whereas allocyclic sequence are the process that are controlled by the external process, that are controlled by the external process, that is the process that are operated from outside the sedimentary basin. This allocyclic process generates cyclic sedimentary succession with greater areal extent than that of autogenic process. Allogenic process may operate simultaneously in different basins in a similar manner, and consequently their product may be controlled over long distances from one basin to another and even possibly from continent to continent. However, the distinction between autocyclic and allocyclic process more often become difficult because both of them are operates simultaneously and their products superposed one above another. For example, regional tectonics may affect the source area outside the basin as well as the depositional basin for siliciclastic setting and may produce redeposition of coarse grain sediments. However, these terminologies are still useful and a relative sense to explain, to emphasize the relative dominance of one above another. The span of the stratigraphic cyclicity varies at least 16 order of magnitude, ranging from the repeat time of birth sweep cycle in turbulent boundary layers, which is of 10 to the power minus 6 years, to plate tectonic cycles involving the formation and breakup of supercontinent. The highest frequency cyclicity of stratigraphic influence is the Milankovitch band cyclicity, ranging in time scale from 10 to the power 4 to 10 to the power 5 years. In the geological record, minor cyclicity may be apparent, results from seasonal fluctuation, storm events, etc., and are known as calendar band cyclicity. The solar band cyclicity generates due to sunspot and other solar processes of time scale 10 to the power 1 to 10 to the power 2 years. The classification implies that the sequence generation is tectonically controlled. Another prerequisite of this classification scheme is the preservation of basin margin in order to understand sequence boundaries. Now, the first order cycle or supercontinent cycle, the highest order long term eustatic cycle resulted from the assembly of supercontinent or their breakup and rifting. These processes have been operated since 2 gigaannum and each cycle spans in time about 400 to 500 million years. Significant changes takes place in global climate and sea level. The major changes in global sea level during the Phanerozoic is well known, and these are due to sea level changes, percent of continental flooding and emplacement of granite magmatism. For 4 such supercontinent cycle has been recorded till now. They are fragmentary. Evidence for several supercontinent cycle during the Precambrian dates back at about 2 gigaannum. All these episodes possibly indicate supercontinent assemblage followed by major dike swarm intrusion, possibly indicating initiation of rifting of another supercontinent. Initiation of rifting of that supercontinent. The Indian craton is flanked by Jurassic to Cretaceous rock resting unconformably over the Gondwanas or Precambrian basement over the wide areas in the eastern and western margin of the craton. Evolutionary changes in the biotic population seem to have post-dated these major orogenic events, indicating blooming in biotic diversity in newly flooded shelf areas. Continental flooding takes place after 50 to 100 million years of sea level rise caused by sea floor spreading and thermal subsidence of the continental margin. Now, the second order cycles with periodicities tens of million years. The second order cycles are global in nature and are attributable with eustatic sea level changes. However, all the major features of this sequence cannot be explained by eustatic sea level changes. These sequences are commonly separated by angular unconformity and contain vast volume of continental deposits. A rise in eustatic sea level would be eroded away widespread non-marine deposits, and thus additional process must be taken into account. Investigations demonstrate that the earth crust is constantly undergoing gentle vertical motion in response to convergent, divergent and transcurrent movement of the plate results broad continental tilts. These type of vertical motion have been termed as epirogeny. Now, the third order cycles with million year periodicities, stratigraphic and facies analysis of well dated Phanerozoic rocks throughout the world have yielded good information about the 1 to 10 million year cyclicity that are referred as third order cycle by Vail et al. In 1977. Evidences of such cyclic sedimentation during the Precambrian are also evident, but difficult in application of this concept remains due to unavailability of accurate chronological data. Stratigraphic reconstruction on the basis of lithologies and biofacies analysis or both have been used for reconstructing the sea level changes. However, there are no statistically reliable procedure for quantifying the sea level curve, that is the amount of sea level fluctuation. The areal extent of these cycles need to be established, whether these cycles are regional or global in scale. Correlation of this cycle across continent are still very limited, and at eustatic curve in global scale are very limited. Fourth and fifth order cycles with periodicities less than 1 million year. The classification scheme constitutes a complete spectrum of classification ranging in age from 1000 years to up to 1 million year. The cycles that spans in time 0.2 to 0.5 million year are considered as fourth order, and those that spans 0.1 to 0.2 are termed as fifth order cycles. There are several types of cycles that are classified on the basis of sedimentological characteristics and tectonics or climatic setting of that area. It is argued that this range of types possibly generated from more than one type of generative mechanism. Sometimes the facies deposited in areas having completely different tectonic histories, indicating that they may be the product of autogenic process. The commonly used informal descriptive term for the sequence is a meter scale cycle. Most of these cycles are of climatic origin. These cycles caused by the process are known as Milankovitch process or Milankovitch mechanism resulting glacioeustasy. The occurrence of upper Paleozoic cyclothems in the northern hemisphere are also possibly caused by this glacioeustasy. Evidence of glacioeustasy for the Cretaceous and early Cenozoic are also quite common. In foreland setting, where cycles may be generated through loading and unloading of crustal material due to compressional tectonism, crustal flexuring, uplift or erosion may lead to change in accommodation space resulting few thousand years. The cycles with age range within 10 to the power 3 years are termed as sub-Milankovitch cycles and are recorded from the ancient rock record. So, in conclusion, sedimentary system like many other natural processes are also cyclic. These sedimentary cycles may be generated by different processes. Those may be autogenic or allogenic. Autogenic processes are those processes which are operated within the basin itself, and allogenic processes are those processes that are operated from outside of the basin. And depending on the process that operated that are responsible for these depositional cycles are and depending on the process that operated such cycles, their areal extent also varies. That means, it may be regional in scale or it may be global in scale, and therefore, these sedimentary cycles can be used for correlation of stratigraphic units which are separated from each other and even in the correlation may be done in global scale. Thank you.